Hey guys, it's Ricky and Cassie here, and we're going to be discussing concepts of one-dimensional motion. Take it away, Cassie.
Thank you for that intro, Ricky. So first, we need to discuss gravity. Gravity is one of the major forces of physics. Now, to kick off this lesson, we're going to describe how gravity affects acceleration. Now, gravity is a force within every object. The greater mass of an object, the greater its gravitational pull. Now, the reason we don't float away and the reason objects fall is because of Earth's gravity. Now, falling object, as we just saw right there, gains acceleration as it comes down from gravity.
And it hurts. A lot.
Now, this object will continue to gain acceleration until it hits a point where it can no longer gain acceleration due to gravity.
As in the floor. Like we just saw. Today, we're talking about free fall. And it's not what you think. You're not falling for free. You're just falling without anything affecting you except gravity. Take it away, Cassie.
So, objects in free fall accelerate at a downward rate. Now, the only thing affecting this object was gravity. No outside force has any effect on that object's acceleration. So, these objects, going with the direction of gravity, will fall downwards.
Like this in the drawing. The little man, pretend it's Mr. Cortez. He jumped off a cliff trying to catch a squirrel that was flying away. Did it work? The world may never know.
He is now in free fall.
Free fall. Next up is air resistance.
Now, earlier we discussed the acceleration due to gravity. Now, there are some factors that can affect this acceleration. One such being air resistance. Now, air resistance occurs when particles are pushing in an opposite direction from gravity. So, as we drop this paper, we see air resistance as the particles push the paper against the direction of gravity. For this reason, if you drop a paper and a marker at the same time, the marker will hit the ground first because it lacks this air resistance quality. Now, if you put these objects in a vacuum where there is no outside factors such as air resistance, both objects will actually hit the ground at the same time because they're being affected at the same rate by acceleration due to gravity.
Particles.
Smarticle particles.
To solve for one-dimensional motion, we look for variables. And when you're looking for the variable, you use these kinematic equations. You don't necessarily have to use every kinematic equation exact, because if you notice here, none of these solve for time. So what you do is there's a thing called manipulation. You can subtract the initial velocity, so it becomes VF minus VI, and then you divide the A, so it's VF minus VI over A. So that would look like this. And you get your time. You can do that for every single one of these.
So, me and Ricky actually forgot to mention where these variables actually came from. Now, the final velocity we know because when you throw an object up in the air, there's a point where it has zero acceleration, so it's actually at a standstill. That would be its final velocity. Now, acceleration, of course, is the acceleration due to gravity. In this case, it's negative since the ball is going upwards. We have a negative 9.8. And lastly, we have our other variable distance. We measured the height that the ball actually went, which was about 6 meters.
Okay, so in order, we have final velocity, acceleration, distance, but we need to find initial velocity. So in order to do that, we need to use a kinematic equation, which would be VF squared equals VI squared plus 2AD. And then we manipulate that by subtracting the 2AD. So it's VF squared minus 2AD equals initial velocity. the VF would be 0 squared minus 2 times 9.8, which is gravity, times 2 times acceleration, which is 9.8, times distance, which is 6. This 0 cancels out. Negative 2 times negative 9.8 would become 19.6. You multiply that times 6.
Oh, it's the same one.
And you get
Is that what you're saying?
117.6. So that equals 117.6, and you find the square root,
You don't get it.
But that's what I'm saying.
and that equals 210.84.
You don't even say okay. Look at your mouth.
And that is your initial velocity.
Oh, that's good.
No, it's not. You're already talking.
So now that we found initial velocity, now we're going to want to solve for time. To solve for time, we're going to use the equation Vf equals Vi plus acceleration times time. Now, since we're looking for time, we can go ahead and manipulate this. We manipulate this. So now we have this equation set to solve for time.
That's actually good. No.
That's good.
So 0 is our initial velocity,